Sir, you can proceed, sir.
Sir, please allow me to share my screen, sir.
Done it, sir.
Yes, sir. It is coming. Okay, 1 second, sir. I'm joining with.
Recording in progress.
Yeah. So, artificial neural networks, they are excellent tools for finding patterns. Means, as a human being, daily how we are doing some activities in order to find out that patterns. So we are using this type of artificial neural networks concepts for a human programmer to extract and teach the machine to recognize. And if you see, what are the artificial neural network concepts today we are going to see? So what are the types of artificial neural networks and what are the applications we are going to solve? And what is the structure of artificial neural network, and what is the working principle, and how do we can use Bayesian network technique. It is a classification technique. Okay, so what are neural networks? See here. So artificial neural networks are electronic models, neuronal structure of the brain. So neural networks. So what is the difference between artificial neural networks and neural networks? Neural networks are not programmed, they learn. The opportunity to study one neural network of the main advantages over traditional algorithms. Whereas artificial neural networks are electronic models, neuronal structure of the brain. So that's why it is called artificial neural networks. So this is the function we are using in an artificial neural network. Like, see how artificial neuron look like. So we are creating a function called sigma I is equal to 1 to n xi minus wi plus b. So w means weights and b stands for bias, and w1, w2, w3, wn weights of connections, and x1, x2, x3, xn are the inputs. So we are calculating the summer function. I mean some function and threshold unit. You can use any activation functions. This is the way we are using trial and error basis x1 to xn, w1 to wn, w1 to wn. This is the artificial neuron, a single neuron, artificial neuron. So same way you can see introduction to artificial neural network, how it look like. See, if you perform take a number of inputs, input layer and a number of hidden layers. See, all yellow circles are input layers and green circles are hidden layers, and from input layers we are feeding the data, and we are adding hidden layers in order to increase the accuracy, and it gives the output to the output layer. If you are doing left to right, it is called feed-forward neural networks, and if you are performing reverse from output to input layer, that is called a back propagation, like forward engineering and reverse engineering. Okay, so then what are artificial neural networks? See here, artificial neural networks are neuronal structure, like See here, number of inputs, number of outputs. See, number of inputs and number of weights. And we are using transfer function called sigma and net input function by using activation function, threshold value. Finally, we are getting the output. So what is the role of neural networks in artificial intelligence? If you see neural networks, it performs the real-time operations, self-organizations concept, and you can call it as a redundant information coding through fault tolerance. Whenever one neuron is not working, remaining neurons are taking initiation to perform the application. That is called a fault tolerance. Advantage of neural networks and adaptive learning. These are the 4 great advantages are playing a vital role in artificial intelligence. If you see architecture of artificial neural networks, this is the structure, number of input layers, number of hidden layers, and finally we are getting the output of the artificial neural networks. Then what are the types of artificial neural networks? If we see, there are 3 important artificial neural networks are there. So feed-forward neural networks, it is used to perform basic pattern and image recognition applications, especially face recognition application. In order to find a twin's face, it is very difficult to recognize. That's why we are using artificial neural networks technique. In order to extract minute features of the image. Then second type is recurrent neural networks. It is used in natural language processing, means conversion of one language to another language, and especially speech recognition. I don't know Chinese. I'm converting Hindi to Chinese, Chinese to Hindi. Such type of applications, we are using recurrent neural networks. Then the last one is a convolutional neural networks. It is used in object recognition and video analysis and image recognition applications. So CNN, it basically is used for object recognition, means image or face recognition and video data analytics, especially video processing applications. We are using convolutional neural networks. Then and a few more types of artificial neural networks like radial basis neural networks, multi-layer perceptron model, and modular neural network, and sequence to sequence models. These are the remaining types of artificial neural networks types. See here how many types of a mostly complete chart of neural networks. Usually what is meant by perceptron? Perceptron is a neuron, it perceiving the information from the input layers and gives the output layer. Feed forward, FF. Feed forward neural network from left to right, if you are performing, then it is called feed forward neural networks. Radial basis network, RBF. Then deep feed forward neural networks, recurrent neural networks, long short-term memory, LSTM, very important in order to solve applications. Okay, video, audio applications, especially speech recognition applications, we are using LSTM. And gated recurrent unit, GRU, and autoencoder, and variational AE, that is one more type, and denoising artificial neural networks, and sparse AE. So these are the various types of neural networks. So red indicates here output cell, and green indicates hidden layers, and yellow circle indicates input cell, and red indicates output cell, and blue indicates recurrent cell, and blue with the double circle is called memory cell, and blue circle with the triangle different memory cell, and pink kernel, like the for recognition of artificial neural networks. So there are neural network rules are there, 5 types of rules: Hebbian learning rule, Perceptron learning rule, Delta learning rule, and correlational learning rule, and outstar learning rule. These are the rules, means we are the way we are using as input, and a number of input, number of hidden layers. We used to follow this learning rules. So that's why machine learning is nothing but learning from the observations. Here, based on the Hebbian learning, according to Hebbian, we are following his rules. Perceptron learning rule is different. Delta learning rule. So now see the differences one by one. Hebbian learning rule. So Hebbian is proposed by Donald O. Hebb. It is one of the first and also easiest learning rules. Learning rules is nothing but, see, if I am explaining, find the area of circle. So once I am telling, then you are calculating by giving X and Y values. Same way, you are learning one example and solving many applications. Same rule we are following in artificial neural networks. And it is used for pattern classification. Hebbian rule works by updating the weights between neurons in the neural network for each training sample. This is the formula we are using. WI. W means weight and new means new weight. WI old weight plus XI and Y. So bias of new equal to bias of old value plus Y value. This is called a Hebbian learning rule. So Hebbian learning rule, also known as Hebb learning rule. It is proposed by Donald O. Hebb. Perceptron learning rule, it states that the algorithm would automatically learn the optimal weight coefficients. The input features are then multiplied with these weights to determine if a neuron fires or not. That means it works or not. Then you can call it as delta learning rule. What is meant by delta learning rule? It is also one of the learning rule developed by Widrow and Hoff. Widrow and Hoff. So this delta learning rule, one of the most common learning rules, it depends on the supervised learning. Supervised learning means we are showing the target class, we are showing the path, you follow this target class and classify the data. That's why it is called supervised learning. Target class or label. See, label means I would like to classify the gender classification, male versus female. So based on the gender label, I'm classifying the data. So this rule states that the modification in sympatric weight of a node is equal to the multiplication of error and the input. Then correlational learning rule, the correlation learning rule based on similar principle as the Hebbian learning rule. So it assumes that weights between responding neurons should be more positive and the weights between neurons with opposite reaction should be more negative. That is called a correlation learning rule. Means similar to Hebbian learning rule. Then the last one is outstar learning rule. Outstar learning rule is proposed by Grossberg in the year 1976. It governs the dynamics of feedback, connections weights in a standard competitive neural network in an unsupervised manner. What is meant by unsupervised manner? There is no label, there is no target class, but you are classifying the data based on the similarity measure. These learning models, how a neuron can learn a top-down template corresponding to, that is, expect or particular input pattern. This is called a outstar learning rule, especially for clustering algorithms. So artificial neural networks applications and algorithms. We are using these artificial neural networks, especially in the image processing applications for classifying the data. If you see the process, how it takes input pattern 0, 0, 0, one image I'm giving as a data acquisition and the pre-processing. That is called input pattern. Then we are selecting the neural network see here. If you see my cursor is moving. So this is the input I am giving to the neural network, and this is the function it calculates, summation function, and we are adding the bias. So any trial and error bias you can add it, and we are following any activation function called ReLU and sigmoid function and softmax. These are the activation functions we are using. And finally, we are getting output. Here we are adjustment of weights and bias. Then finally, we are getting the results, decision making, decision boundary. So how many values are 1? How many values are 0? So that is called a data representation. So this is the way the artificial neural networks process. Then if you see, how do artificial neural networks work? If you see, artificial neural networks use different layers of mathematical processing to make sense of the information it's fed. So based on the mathematical processing, how many calculations do you like? An artificial neural network has anywhere from dozens to millions of artificial neurons called units or nodes arranged in a series of layers. The input layer receives various forms of information from the outside world. Yes, we are using number of input layers and a number of hidden layers. This is the data that the network aims to process or learn about from the input unit. The data goes through one or more hidden units. So the hidden unit's job is to transform the input into something the output unit can use. So this is the way artificial neural networks works. See example, what are the advantages of neural networks? So this is architecture. See, if you take sensory layer, like all green circles are input layers, 1 to 6, and 1 to are the output layers. And here you can see that 1 indicates that yellowness, and 2 indicates that greenness, 3 indicates longness, 4 indicates roundness, 5 indicates white flesh, 6 indicate thick P-label skin. Now I want to calculate weights of a matrix. See here, connections with the input layer, connections with the weights. So we are developing a weight matrix, I for rows, J for columns. So number of rows are 2, number of columns are 6. So 2 by 6 means 12 items we are getting in this weight matrix. This is the way, say, number of input layers, here number of columns, and the number of output yellow is number of rows. So each value you are getting some values. That is called artificial neural network process. Artificial neural network softwares. What are the softwares? It is used to simulate. Simulation purpose we are using, for research purpose, for develop applications and apply artificial neural networks, etc. So for research simulators, data analysis simulators, built-in visualization to monitor the training process, simulate the behavior of artificial or biological neural networks. These are the what are the softwares we are using in order to perform various applications. Artificial neural networks classified into 3 types: learning paradigms, learning algorithms, topologies. What are the learning paradigms? Means models like supervised learning, approaches. Paradigm is nothing but approaches. Supervised learning, unsupervised learning, unsupervised learning. See here, supervised learning means we are using label and target class. Based on label, we are classifying male versus female. That is called a label. That's why it is called a supervised learning. Unsupervised learning means I don't know how many classes are presented in this group. So I would like to classify the data based on the similarity measure. There is no target class, there is no label, but based on the similarity measure, I am classifying the data. That is called a clustering, especially. Then learning algorithms like a conjugate gradient and quasi-network, quasi-Newton, steepest descent. These are the learning algorithms. So based on the learning pattern, learning model, it will calculate automatically. Then topologies means networks, single layer network, multi-layer network, networks with one recurrent layer. These are called topologies. Then see the one typical how to design a neural network. See neural networks first pass an input like an image through multiple layers of digital neurons. Each layer reveals additional features of the input, like mathematicians are revealing how networks architecture, how many neurons and layers it has and how they are connected. It determines the kinds of tasks that the neural network will be good at. See here, input I'm taking as a dog. So in this image, I'm taking as a input as a dog, image broken into number of pixels. See, image is nothing but a combination of pixels. Pixel is a point or position. Okay, so that's why what is your picture resolution, image resolution? Like our laptop resolution is 1024 by 760 resolution, x-axis and y-axis. Like here I'm taking as a dog as an input image, then converted into layer 1 number of pixel values detected. Then layer 2, what we are doing? Edges we are identifying. Then layer 3, combinations of edges identified. Layer 4, what we are doing? Features identified. And layer 5, combinations of features identified. Finally, we recognize output as a dog. So like that, I'm giving number of inputs like dog, cows, buffaloes. But I want to classify only dogs, only buffaloes, only cows. By that time, we are using this artificial neural networks concept. So very, very important for artificial neural networks for classification applications. When data is fed into a network, each artificial neuron that fires means labeled 1, transmits signals to certain neurons in the next layer, which are likely to fire if multiple signals are received. This process reveals abstract information about the input. So if you see one example here, first one at the bottom, a shallow network has a few layers but many neurons per layer. These expressive networks are computationally intensive. If you want to solve complex applications, we are using such type of shallow network. A deep network has many layers and relatively few neurons per layer. It can achieve high levels of abstraction using relatively few neurons. So from this concept only we got it, deep learning concept. Are you understanding? Deep learning concept from the artificial neural networks only it came. If you see this, this is called a mind map. This image is called a mind map. So in this artificial neural networks, how many concepts we are studying? See here, multi-layer perceptron, that is called MLP, and recurrent neural networks. So there we can see long short-term memory, LSM, and gated recurrent unit, and autoencoders, and sequence to sequence. Then DCNN, deep convolutional neural network, that is called CNN, and modular neural networks. If you see reinforcement learning, what are the algorithms we can see? A3C, genetic algorithm, SARSA, and O learning, deep Q network. See, then if you see machine learning, it extends to the ensemble learning. In ensemble learning, we are having three types like boosting, bagging, stacking. Bagging, we are using random forest. Boosting, we are using AdaBoost algorithm, XGBoost, gradient boost, cat boost, and light gradient boost machine learning algorithm. Then classical learning, we are having two types, like supervised learning and unsupervised learning. Supervised learning, we are classification and regression. In classification, we are using decision tree, support vector machine, naive Bayes, classification, logistic regression, and k-nearest neighbor. Then regression, we are using linear regression and polynomial regression and lasso and ridge regression. Unsupervised learning, we are having three types: pattern search, clustering, dimensionality reduction, and visualization. Clustering, we are using fuzzy C means clustering, K means clustering, DB scan, and mean shift. Dimensionality reduction and visualization, we are using principal component analysis, linear discriminant analysis, support vector discrimination, like various dimensionality reductions. Pattern search, we are using UCAT, a priori, FP growth. And UCAT, a priori, and FP growth are the frequent pattern mining algorithms. So these are the neural network algorithms, very famous algorithms: gradient descent, evolutionary algorithms, and genetic algorithms. Very popular, three important algorithms. Especially gradient descent algorithm. So gradient descent is one of the main order iterative optimization algorithm for finding a local minimum of a differentiable function. The idea is to prepare repeated steps in the opposite direction of the gradient or approximate gradient of the function at the current point. If you see this gradient descent algorithm, in order to find the local minimum of a differentiable functions. So for especially repeated steps, if you are following in the opposite direction of the gradient of the function at the current point, because this is the direction of steepest descent, that is called a gradient descent algorithm. It follows the steps like choose an initial random value of weight, that is called W, choose the number of maximum iterations called T, choose a value for the learning rate. Okay, so N belongs to A, B, then repeat following two steps until F does not change or iterations exceed the maximum iteration T, or a compute delta weight equal to minus N delta weight function of f of w and bias, and B updated new as weight equal to weight plus delta weight. This is called a gradient descent algorithm. In the second year level, you may not understand this concept is very complex concept. From this concept only, we got machine learning and deep learning concept. Keep in mind, it is bit difficult to digest these concepts, my dear students. Soon I am going to end with the neural networks, and one algorithm I am going to demonstrate, and followed by the machine learning. Very interesting concept. Then second one is evolutionary algorithm. So evolutionary algorithm is based on concepts of biological evolution. How as a human being started with monkey, then and goes on evolution, came as a man, came as a human being. Okay, so a population of possible solutions to the problem is first created with each solution being scored using a fitness function that indicates how good they are. The population evolves over time, and hopefully it identifies better solutions. As the name suggests, evolutionary algorithms mimic natural selection, where only the fittest individuals survive through the process of mutation, selection, and crossover. These are the operations we are performing evolutionary algorithm. It is just like a biological evolution. How as a from child to, infant, baby to child, child to adult, adult to old age. So for the genetic algorithm, each candidate solution has a set of properties or genes which can mutate or change until we find the best solution. That is called a evolutionary algorithm. The last one is genetic algorithm. So genetic algorithm is such a heuristic algorithm, is inspired by the Charles Darwin's theory. Charles Darwin's theory. You might have studied in a biology subject in 8th and 9th grade, Darwin's theory of natural evolution. Based on that concept, this genetic algorithm is very popular in order to classify the data. This algorithm reflects the process of natural selection, where the fittest individuals are selected for reproduction in order to produce offspring of the next generation. This is the steps this genetic algorithm is used to follow. First, we are initializing the values, input values, and hidden values. Then fitness assignment, what type of fitness you would like to calculate, that is called mathematical function, selection, crossover, mutation, and we are checking the condition. If it is true, it will use the output. If it falls, again it will learn the algorithm. That is called a genetic algorithm. So with this one, the theory part I am going to concluding of artificial neural networks, where we are using applications of neural networks. See here, handwriting recognition, because same type of signatures are available or not. Some intruders, some cyber attackers are using these handwritten recognition applications. Image compression, I am reducing size of the images. There also I am using neural networks. And a traveling salesman problem, where is the shortest path between source to destination? That is called a traveling salesman problem. And a stock exchange prediction. There also we are using this artificial neural networks applications. And ANN algorithm, it is very popular and very interested algorithm. ANN uses the processing of the brain as a basis to develop algorithms that can be used to model complex patterns and prediction problems. So we have to predict columns X. A prediction closer to 1 indicates the customer has more chances to default. That is the ANN algorithm. in ANN implementation in Python, see here, first we need to take the input data set. I'm taking input data sets as a flowers. Okay, all flowers, all types of flowers I'm taking as input data sets. Suppose 1000 images of flowers. I don't know what is the rose. I don't know what is a lily, because all are mixed in a database. Now I want to classify the data. So how do you classify the data of images of flowers? Based on the properties. If it is red color, you can classify the rose. If it is white color, you can classify the lily, like that. So that data pre-processing means we are removing the noisy data of the image, inconsistent data, dirty data. That is called data pre-processing. Then import the libraries like Matplotlib, scikit-learn, pandas, keras, TensorFlow. Those are the import the libraries, load the data set. Data set means image data set we are taking as in split data set into X and Y. Yes. Then encode categorical data, split the X and Y data set into the training set and the test set, perform feature scaling, build artificial neural network, import the keras libraries and packages, initialize the artificial neural network, add the input layer and the first hidden layer, add the second hidden layer, add the output layer, train the ANN, compile the ANN, fit the ANN to the training set, predict the test set results, make the confusion matrix in order to classify the accuracy. This is the ANN algorithm steps we are using. So same steps, whatever I have explained, same steps are available in this ANN algorithm. Assign random weights to all the linkages to start the algorithm. Using inputs and the hidden linkages, find the achievement rate of hidden nodes. Using the activation rate of hidden nodes and the linkages to output, find the activation rate of output nodes. Find the error rate at the output node and recalibrate all the linkages between hidden nodes and output nodes. Using the weights and error found at output node, cascade down the error to hidden nodes. So these are the steps of ANN algorithm. So these steps I have explained. Now, so these are the steps, simple steps. See here, data pre-processing, import the libraries, load the data set, split data set into X and Y, encode categorical data, split the X and Y data set into the training set and the test data, perform feature scaling, build artificial neural network. Hello, my dear students. Now with this one, I am closing the theory session. Now see the algorithm I am going to explain. I am going to demonstrate one application. See, this is the implementing artificial neural network training process in Python. How to do training process? Training means, suppose 100 images you have taken as a face recognition applications. So 75 images I am doing training and 25 images I am taking testing. So training, what I am doing, I am calculating all the features of face. So the distance between eyebrows, the distance between forehead, the distance between nose and mouth, and the distance between chin and forehead, like that. Number of moles on the face. We are calculating number of features. So that is called number of features, especially face recognition. We are training number of features. If you are increasing number of features, constraints, automatically your accuracy will increase. That is called how to do training process. I am going to explain now. So first I am importing NumPy package in order to calculate mathematical operation. Then I'm using neural net as my class name, and I'm defining a function init that is called constructor for initialization purpose, then generate random numbers. So one function I am using random function and assign random weights. See, this is assign a random weights. You can call it as, it is also comment section. Then the sigmoid function we are calculating. Then the derivative of the sigmoid function. This is gradient of the sigmoid curve. Then train the neural network and adjust the weights each time. Then pass the training set through the network. Then see the calculate the error. The neural network thinks. Then initialize the value. Then the training set. See, I'm taking inputs 0, 1, 1, 1, 0, 0, 1, 0, 1. And output array, I'm taking 1, 0, 1. So I'm calculating with the output value. Train the neural network. I'm using function directly. And inputs, outputs, I'm calculating 10,000 iterations. I'm applying 10,000 iterations. Test the neural network with a test sample like 101. This pattern is there or not? I'm finding in the input data set. I'm testing with the 101. Is there or not? Yes. So it is calculated 0.98 output. Now please see output of please see the output of this training algorithm. I'm going to share with you this see CMD. So I'm sharing this code. You can see the check Python version. So 3.11.1. My dear students, please open your laptops. So quit. So I'm checking. See, why quit? It is not allowed because Python is a case sensitive programming language. There is a difference between small a and a capital A values. So that's why Python is a case sensitive programming language. It can allow only small case letters, lower case letters. That's why it is showing error. Now see here, notepad space ANN.py. I have given the name artificial neural networks first program. Py means Python extension. I'm opening in the notepad. Now see, same program just now I have explained. Implementing artificial neural network training process. How to do training process in Python. Okay. So now I'm going to execute. See here, I'm sharing this file to you. Python space ANN1.py. Now it is calculating the output. See, I got the output 0.98 means 101. In the input data set, 101 is there or not? Yes. If you see the program, I have given input data set here. See here, inputs array 011, 100, 101. Yes. Now I'm expecting, I'm testing with the value 101. Yes. So almost all 1. That means it is calculated 1000 iteration. Yes, it proved that. Yes. 0.98.97% I got. Yes. 101 is presented in the input data set. This is the way we are training the process. Okay. And now see here, I'm sharing this this program. Okay. I'm sharing this program. 1 second. So I'm giving this program. Please execute I'm giving to you in the WhatsApp. Please open all of you WhatsApp. Check your WhatsApp and execute this program. I'm sharing in the data science workshop group. Just you copy in the C colon users where you have you are executing programs. You can download this file and in this path. See, in my system, there is a path called C colon users Sharavati. So in this folder, you can save like in your system, like Bhavita, her path is C colon users Dell something. I think Bhavita, your system is ready for executing all the programs, or still it is giving problems?
Sir, we changed the system, sir.
Oh, very good. Now you can execute this program. I have shared in the WhatsApp. Please execute.
Okay, sir.
Yeah, please do it. How many of you executed? Please raise your hand in the chat box. Please execute. Sir, please show students camera, sir, so that whether they are doing or not, I can find out. Hello, sir. Please show camera to the students' view, sir. Ramana, sir.
Yes, sir.
Yeah, please share a screen to the students' view camera, so that whether they are doing or talking, I would like to find out. Please show camera to the student directions, madam.
Okay, sir. Okay, sir. Sir, is this well?
No, madam, it is not. Yeah, it's no. My camera is visualizing, madam. No. Student camera you can display, madam.
Okay, sir.
Sir,
So yes, it is coming or not?
one send program, sir.
Yeah, please open your. Sorry, what is your doubt?
Please send program, sir, once again.
Yeah, I'm sending. Okay, 1 second. I have sent a file, directly file. It's okay. I'm sending program in the WhatsApp group. You can copy, paste, or directly I have sent the file also. Directly you can download the file, a Python file, ANN1. That file you can copy in the C colon users in your drive, in your folder. Then you can execute. So you need to get the value 0.98. How many participants got it 0.98? Please, you raise your hand in the chat box. Yeah. You got it? File name notepad space ann.py. Notepad space ann1.py. You got it or not? Please raise your hand. You can open WhatsApp or you can copy through pen drive.
A few members.
Hello?
Few members.
Okay, okay. What is the error, madam? Please share your screen. Just what you have to do, you just download that file as it is in the C colon or users, then a folder. Then go to file, first open notepad space ann.py, then Python space ann1.py. Okay. Number of participants. Yeah, now it is coming. Yeah, please share your screen. Hello, please unmute yourself and ask me the. Yeah, now it is okay. Students are doing. Okay. Now, yeah, please. Indentation error, I think. The way you have copied. Do one thing. Whose system? This one? Show me path C colon users admin. Go to just go to your WhatsApp. Please go to WhatsApp. You please close notepad file. Please close notepad file. Yeah, this one you can close it. Yeah, go to WhatsApp file. I have shared ANN1 file. Just go click. I have shared the file. You can down. Yeah, please download that file. Not this one. Just go up. Yes, download. Yes. Yeah, you copy that file. Wait. You copy. Go to there. Yeah, show folder. Copy. First one, ANN 1. Not this one. Yes. Copy, Control C. Go to C colon. Yes. Go to C colon. The path you have showed to me. Python C colon users. Yes. Users. In the admin. Yeah. Control V. Just to do Control V. Yes. Replace in the file. Yes. Now go to run command. No, it's okay. Go to run command. CLS clear screen. Python. First check the Python version. Python. PYTHON. Enter. Yes, correct. Quit. QUIT. Parenthesis begin. Parenthesis close. Enter. CLS clear screen. Python's open notepad first. Notepad file. Notepad space ANN.py. No. ANN1. Yeah, ANN1.py. Py. Enter. Yes, because your file is not recognizing. Okay. So do one thing. Notepad, that means in the admin folder, it is not copied. Just go to C drive. Go to C drive. Otherwise, you do one thing. Go to C drive. Yes. Users. Go to C drive. Users. C colon users. Open admin. Yes. Here, ANN. Yes. Right click there. Right click. Right click on ANN1. No. ANN1. Yeah. Select ANN1. Right click. Yeah. Open with notepad. No. Just go to open with notepad. Below. Yes. Open with. Yeah. Here, choose another app. Yeah. Because your notepad is not recognizing here. That's why. Choose another app. Yes. Select. Yeah. Come down. More apps. No. Go to more apps. Below. Yes. There you can see where is the notepad file. Yeah, notepad here. Yes. Open. Okay. Yes, now it is recognized. Okay, save. Save the file. Yes. Now minimize. Yeah. Now you can execute. CLS, first notepad. Same, use up arrow, it will come as it is. Up arrow. Notepad space ANN1.py. Yes, open. See, still it is not recognizing. That is the problem. You do one thing. You have opened that file. Show me notepad file. Show me notepad file. Here, go to file. Here, go to file. Go to file. Save as. Yeah, wait. Go to C drive. Go to C drive. Yeah, select users. Select. Yes, select admin. Double click. Now ANN.py. Last. ANN.py. Below you can select all files. Yeah, select all files. Yes, save. Yes, because your system is not recognizing notepad file. That's why it is showing. It is not a problem. because your system unable to recognize. Now close and run the program. Python space. Close this one. Close. Yeah, Python space. ANN1.py. Enter. Yeah, you got the output. Perfect. Congratulations. So this is called a training process. I think everybody executed. Say respond.
Yes,
Okay.
sir.
Okay. Now I am sharing next very interesting subject called my screen is visible. Yeah. Now see machine learning. Next 8th subject is machine learning. What is meant by machine learning? Machine learning is the study of computer algorithms that improve automatically through experience. Now you got how to do Python programs experience. See, in your system, it is not recognizing Notepad as a external or a internal command. Now we have opened, we have trained once. We have opened with Notepad. Now your system recognizes, yes, that file is available in the C:users and admin. That is called learning experience. So once you show the path, next time onwards, it will execute all the files automatically. That is called a machine learning. So machine learning provides smart alternatives to analyze vast volumes of data by developing fast and efficient algorithms and data-driven models for real-time processing of data. Machine learning can produce accurate results and analysis. The field of machine learning is concerned with the question of how to construct computer programs that automatically improve with your experience. See, now you are the students are experienced with Python programs. One program I have shown, remaining programs you are executing your own experience. That is called I'm training you as a model. So same way, if you write a computer program that automatically improve the experience from the mistakes it is learning. Best example, you are playing with the computer chess game. You play computer chess game with the computer. Always we are losing because it is already trained and it learns mistakes itself. It improves the experience by mistakes. So if you write one time IIT exam, you cannot crack. Next time you are cracking because you are learning from the mistakes. So Tom Mitchell explained the field of machine learning is concerned with the question of how to construct computer programs that automatically improve with experience. So what is the technical name of this image? See, I have incorporated inference, predictions, intelligence, strategy, pattern, everything. The technical name of this image is called machine learning word cloud. Next. So machine learning algorithms utilize variety of techniques to handle large amounts of complex data to make decisions. So these algorithms complete the task of learning from data with specific inputs given to the machine. So first we are doing training, then model creation, prediction, analysis, retraining. If you are not getting good accuracy, then retraining. Prediction is the cycle of any machine learning algorithm. This enables the machine learning algorithms to learn on its own and produce an optimal answer that will gradually increase in accuracy over time. See the machine learning algorithm approaches. I have explained 3 approaches. Like supervised learning means there is a label, there is a target class. We are dividing into the groups. classes, classification, like classification regression. Classification, we are having important algorithms like naive Bayes algorithm, SVM algorithm, K nearest neighbor. Those are the classification algorithm. Then regression algorithms, we know decision tree, linear regression, logistic regression. It is comes under supervised learning. Unsupervised learning, there is no label, there is no target class, but we are dividing the groups or classifications by using similarity measure, based on the similarity measure. How do you calculate similarity measure? By using Euclidean distance. So if you see K-means clustering, mean shift, K-medoids, that is called clustering. Then dimensionality reduction, principal component analysis, PCA. Then you can call it as a feature selection, linear discriminant analysis. Then the third approach is reinforcement learning, especially gaming applications. So how to explain introduction to machine learning? See here, first we are taking ordinary system with input values, and you can choose with the AI, then choose the machine learning algorithm, and your model is predicts the results and learning itself, and finally it improves the results. This is the way we are using machine learning. There are three types of machine learning algorithms in there are three approaches: supervised learning, unsupervised learning, reinforcement learning. My dear students, you just remember what is meant by supervised learning. So based on the task driven, means all data is labeled, you know, male, female, easily you can identify. So, and the algorithms learn to predict the output from the input data based on the task driven. That is called supervised learning. Unsupervised learning, all data is unlabeled and the algorithms learn to inherit structure from the input data. That is called data driven. Data is huge. Data is a vast volume of data. Then reinforcement learning, it works on interacting with the environment, whereas the supervised learning method works on given sample data or example. That is called learning from the errors. That is called reinforcement learning. See examples. Supervised learning, I have already explained. What is meant by supervised learning? The algorithms learn the relationship between specific inputs and outputs based on training data and human feedback. So those are regression and classification. Unsupervised learning means the algorithms analyzes the data for trends and patterns without being given a specific output variable or human feedback. Example, clustering, dimension reduction. Then reinforcement learning, the algorithm learns over time, maximize returns based on the rewards it receives for performing certain actions. That is called reinforcement learning, especially model-free, model-based. So these are the types of machine learning approaches: supervised learning based on the task-driven, unsupervised learning based on the data-driven, and reinforcement learning from the errors. So machine learning process, see first, we are taking as input big data sets. So we are learning, we are training the data. Then we are applying machine learning algorithm, big model. Then we are predicting the output results, inference. What is the output? So you can ask the query or you can take the decision. That is called a machine learning process. Machine learning life cycle is, first we are collecting the data selection, means data gathering. We are collecting the data sets. You can take weather forecasting, supermarket data, and NASA data, traffic data analytics, healthcare data. See, now I would like to classify COVID-19 virus of chest X-ray images. I'm taking chest X-ray image as input. I'm applying CNN algorithm. I am classifying that the image belongs to positive or negative. That is called data gathering, then data preparation, data wrangling. Data wrangling means any noisy data or any inconsistent data is there, then we are performing data wrangling. Then data analysis, we are analyzing how many types of images are there, how many rows and how many columns. And model training. Model means simplified version of the reality. We are training, suppose 100 images are there, 75 images are training, 25 testing. Model testing and deployment. Finally, that application is we are deploying. Then machine learning, how does machine learning works? First, we are taking input data, then analyze data, find patterns, then prediction of the data, store the feedback. That is called machine learning work. Then see the machine learning examples, where we are using machine learning examples, self-driving cars especially. Very interested applications we are solving with help of machine learning examples. Self-driving cars, predicting an illness. See, nowadays, we are getting cough and cold. So a doctor is suspecting maybe COVID-19. That is called predicting an illness, credit card worthiness, ranking on social media, CV in agriculture. I mean computer vision. CV means not curriculum vitae. Please keep in mind. Computer vision, okay, in agriculture, targeted emails, question and answers based platforms, fashion industry. So we are using machine learning examples. Then see the example. One of the small example I'm going to explain, reinforcement learning. So I will ask you questions. So here, intelligent robot is there. So left side bucket full of water with bucket, and right side there is a flame, fire is there. Okay. Now intelligent robot is thinking. Now we are training the model now, environment and agent. First we are selecting the observe. We are training the, we are giving instruction to the robot. Hello robot, you observe what are the objects are there, what are the items are there. Robot is saying yes. In my left side there is a tap and a bucket. There is right side there is a flame and a fire. Okay, very good. Next instructions I'm developing. Select action using policy. So I'm giving the instruction. So select action using policy. I'm giving some rules and regulation. Please listen. Action. So immediately robot moved wrongly to the right direction. The robot fire is, oh, it is hot. Immediately I gave punishment. 50 minus 50 points I'm reducing intelligent agent. So get reward or penalty. I'm based on this action. I'm giving reward penalty because minus 50 points. Then next time it cannot repeat same step. Then update the policy, learning step. Update the policy is nothing but learning step. Now, if fire is there, equal to bad step. I'm writing bad instruction. Next time, avoid it. Then here, it will perform next step. Oh, yes, there is a fire. That's why I will take full of water with bucket and I'll pour it. So iterate until an optimal policy is found. So intelligent agent has done tremendous job. Finally, the full of water with bucket, it pour on fire, fire gets rid of. So this is way reinforcement learning works based on the punishment and reward. Okay. Penalty, punishment and reward. We are solving this reinforcement learning applications, especially gaming applications. So machine learning approaches I have explained already. Supervised learning, unsupervised learning, reinforcement learning, neural networks and deep learning, ensemble learning. See, remaining three I have explained already: supervised, unsupervised, reinforcement. Apart from ensemble learning. Ensemble learning uses stacking, bagging, and boosting. Then a neural network and deep learning uses convolutional neural network, CNN, recurrent neural network, RNN, generative adversarial network, that is called GAN, especially for face recognition application, we are using GANs. Then autoencoders and Perceptron. These are the neural network and deep learning models. Then see the predictive analytics strategy, how it works. First, processing. So Michigan data set. I am taking one data set of Ravindra Engineering College for Women. First year data. First year data means first year results data. In Excel sheet, I am taking how many students attempted first semester, how many students are got passed, how many students failed in one subject, like that sort of information. That is called data set I am taking. Then I am doing feature selection. Feature selection means how many males and how many females are there, how many rows and how many columns are there, and how many got 75% above, like modeling with five-fold cross validation, like evaluation metric, accuracy, sensitivity, like. Then television Avive data set. Here also I'm using feature selection, modeling, five-fold cross validation. Then Michigan plus television of data set. I'm using feature selection, performing, training plus validation. Okay, this is the way prediction analytics strategy works. Then see the traditional programming and the machine learning. How traditional programming it works and how machine learning can help us to solve applications. Now see here, traditional systems like data program to the computer, you are giving input data and handcrafted model. Then finally you are getting results. Whereas in machine learning, you are giving data as input to the system and again output also giving input to the system. Then your computer is recognizing model and that model gives us result. This is called a machine learning. So learning, prediction, we are performing in this one. Then these are the algorithms I have explained, types of machine learning approaches: supervised learning, unsupervised learning, reinforcement learning. So classification, regression, dimensionality reduction, clustering, and gaming, finance sector, manufacturing, inventory management, and robot navigation. See, unsupervised learning, we are using dimensionality prediction for text mining applications, face recognition applications, big data visualization applications, and image recognition. Clustering, we are using biology data applications, city planning applications, and targeted marketing. Classification, we are using fraud detection, especially in banking system. Then email spam filter classification algorithm. Then diagnostic image classification. Then clustering, which I have explained, and dimensionality reduction. Then gaming, in gaming, finance sector, manufacturing, inventory management, robot navigation, especially intelligent agents are working in a reinforcement learning in order to solve complex applications of robot. Then these are the algorithms are very famous under supervised, under regression, linear, polynomial, decision tree, random forest, classification, KNN, K nearest neighbor, trees, logistic regression, naive Bayes, support vector machine. Unsupervised clustering. Clustering means group of objects that objects are having similar behavior. SVD, support vector dimension, principal component analysis, K-means. Association analytics, we are using two algorithms. One is a priori and one more is FP growth. Frequent pattern mining growth. Then we'll see the reinforcement algorithm, continuous and categorical. These are the examples of machine learning. These are few more examples of machine learning. I have explained classification. See, supervised learning means data with label. Okay. Bhavita, can you read? Can you read? Because it is repetition for me. Can you read once again this slide? It is visible?
Yes, sir.
Yeah, please read now. I have explained already. Now you explain this slide. Machine learning is classified into 3 types like that. Start with Bhavita. Unmute yourself and explain.
Machine learning is classified into 3 types. Second is unsupervised learning. Third is
It's okay. Why it is coming noise? Because okay. Listen, I'll explain, listen. So simply you can remember what is meant by supervised learning. Data with labels, sir. There is a name, there is a target class. Unsupervised learning means data without label, but you have to classify the data. That is called unsupervised learning. Reinforcement learning, state and action. That means punishment and reward. So under supervised learning, we are having a classification and regression. Under unsupervised learning, we are having clustering, association rule mining, dimensionality reduction. Whereas reinforcement learning, we are having a model free and model based. See, if you see classification algorithm, example, linear regression, naive Bayes classifier, K nearest neighbor, support vector mission. Examples, email spam detection, speech recognition. Regression, linear regression, ridge regression, ordinary least squares regression, stepwise regression. Example, stock market prediction and rainfall prediction. And if you see clustering, there are various algorithms like K-means, K-medoid, hierarchical clustering, exception, maximization. Example, identifying fake news, document analysis. Then as association analysis, we are having a priori, ECLAT, FP growth. Example, market basket analysis. Dimensionality reduction, we are having feature extraction. Principal component analysis, feature selection, wrapper, filter, embedded method. Example, analysis of written text and DNA microarray data. State and action, a model free, Q learning, hybrid policy optimization. Model based, learn with model, learn the model, give the model. I think Somasekar, you are having one doubt, please ask me. Unmute yourself and ask me doubt. You are raising hand. What is your doubt? Somasekar. What is your doubt, Somasekar? Okay, my dear students, any doubts, please ask me. So these examples I have explained already. All types of examples. Okay, example programs I have explained. And this is also I have explained supervised learning, unsupervised learning, reinforcement learning, examples. See, especially reinforcement learning, real-time decisions, game AI, learning task, skill acquisition, robot navigation. Remaining all are I have explained already. These are different types of algorithms. And these are the machine learning algorithms. These are the machine learning algorithms we are using. Statistical mathematical methods, like we are using various tools, R and Scilab, SAS, SPSS, PSPP, stats models, SciPy, NumPy. For machine learning tools, see here, general purpose we are using scikit-learn, Veka3, RapidMiner, MATLAB, Octave, Shogun. Then narrowed solutions, XGBoost, OPAL-Wabet, LibSVM, and NLTK, Natural Language Toolkit, and Gensim. Then interactive platforms, we are having Jupyter, Zeppelin, Orange, Kibana, Grafana, Tableau. Machine learning, deep learning with MapReduce, we are using deep learning 4J, H2O, Deepwater, SparkML, and MLlib. FlinkML, RCX2ML. Then deep learning with GPU, graphical processing unit, we are having various algorithms, TensorFlow, and convolutional neural network kit, Caffe, Caffe2, Torch, PyTorch, MaxNet, Theano, and Chainer, Paddle, Mat Convenient Net, deep learning wrapper libraries like Keras, Gluon, TensorLayer, TensorFlow, Learn, 9, NVIDIA Digits. These are the various algorithms. So these concepts I have already explained. Examples of reinforcement learning, see, real-time decisions, game AI, robot navigation, skill acquisition, learning task. So machine learning roadmap, first we need to select, you need to have mathematics knowledge like probability, statistics, and discrete statistics, discrete mathematical structures. Then any one programming called Python or Java, then database called MySQL, Mongo database. Then you can choose machine learning, scikit-learn, supervised learning, and linear supervised learning, and reinforcement learning. Machine learning means ML libraries and non-machine learning libraries. ML algorithms like linear, logistic, and non-linear regression. Then deep learning, we are using TensorFlow, Keras, neural networks, CNN, RNN, GAN, LST. Data visualization tools, Tableau, ClickView, Power BI. Then machine learning engineering. So these are the machine learning approaches. These are the machine learning process. Machine learning analytical tools. See, we are having statistical tools like R, Pandas, Suppose data sets are there, we are using pandas exploratory data analysis tool. Then predictive model, markup languages are there, PMML, and scikit-learn, machine learning model builders, portable formats for analytics, Mongo database for scriptable databases, Storm real-time analytics, Hadoop for MapReduce, iterative analytics for Spark, and client-side web browsers, GPUs and co-processors, and FPGAs and ASIC. These are the machine learning tools. So these are the machine learning softwares: Weka, Apache Spark, RapidMiner, H2O, Shogun, NIME, and RCX2, Apache Mahout, PyTorch, TensorFlow, Keras. Advantages and disadvantages. So advantages: easily identifies trends and patterns, no human intervention needed, continuous improvement, handling multidimensional and multi-variety data. Fifth one is wide applications. So disadvantages like a high error susceptibility, data acquisition, time and resources, interpretation of results. These are the applications of machine learning. We are using image and speech recognition applications, medical diagnosis applications, statistical arbitrage, learning associations, classification, prediction, extraction, regression. These are the applications of machine learning. And a few more applications. See here, automatic language translation, like English to Telugu, Telugu to English. Medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, email spam and malware filtering, self-driving cars, predictive recommendations, traffic predictions, speech recognition, image recognition. Next, these are the various concepts under supervised learning, unsupervised learning, and reinforcement learning. These are the examples. Then these are the mathematical formulas we are using. Naive-Bayes formula, K nearest neighbor formula, support vector formula, neural networks, backpropagation, gradient, linear regression, principal component, logistic. So these are the challenges faced by machine professionals. Poor data means data having poor quality. Underfitting training data, overfitting data. You are training with image data set. Sometimes you are means number of steps. You are passing the number of steps. That are overfitting. Underfitting means 10 steps we are expecting, but you got only 2 steps. That's called underfitting. Lack of data, that is a challenge. Interpretation, emissions algorithm when data. This is also happening nowadays. State is R&D. And what are the learning libraries for 2021? So 2022 also NumPy, scikit-learn, Theano, TensorFlow, Keras, PyTorch, and these are top machine algorithms for predictions. Regression, logistic regression, decision tree, random forest, clustering boost, clustering networks. Right side, the diagrams look like. And you can see various concepts, neural networks, gradient boosting, random forest, definition, description, advantages and disadvantages. Okay. I'll explain that application so that you can understand. These are the top 5 classification algorithms I'm going to demonstrating now. Please, first application under machine learning, logistic regression. Logistic regression is a statistical model that in its basic form uses a logistic function to model a binary dependent variable, although many more complex extensions exist. It is estimating the parameters of logistic model, a form of binary regression, means 1 for true, 0 for false. Logistic regression is used when the dependent variable is binary in the nature. So logistic regression measures the relationship between the categorical dependent variable and one or more independent variables by estimating probabilities using logistic function, which is the cumulative distribution function of logistic distribution. So this is the output I'm expecting. First one is a linear regression, y is equal to mx plus c. And the second one is a logistic regression. Okay. Sine wave, sinusoidal wave. And logistic regression algorithm, it follows the number of input layers, then number of hidden layers, then linear model and a sigmoid function for activation function. Then finally we are getting 0 or 1. This is the code I have explained. See, listen, import matplotlib. I think you have executed this one. Please, can you execute once again? Logistic regression, please. I'm sharing this code in the group. Please execute once again. Because if I'm explaining continuously theory, you will feel bored. Now, you can execute. Please execute. See here, I'm going to execute now. Notepad, space, logistic, logistic.py. Import matplotlib. Okay. Import numpy as np from sklearn. Okay. And I'm finding the, listen carefully. I'm importing matplotlib for graphs. Import numpy for a mathematical calculation from sklearn. Sklearn is a package. Under that, logistic regression is presented. Then from sklearn, metric import classification, report confusion matrix, then import matplotlib as PLT. Then x and y values I'm taking. X values np dot arrange of 10 values randomly dot reshape -1, 1. This is the sample example I'm taking, and y values I'm predicting. np dot array 4 zeros, 6 ones. Print x and y. And you can call it as model. Directly I'm using logistic regression. So here model fit x comma y, logistic regression. I'm using 1.0. So then model linear logistic regression directly I'm using, and calculating predicted classes, intercept, coefficient, predicted value. Finally, I'm plotting the graph. Model dot predicted probabilities. Okay. Now please execute, all of you. Share your screen if you are not getting. Python space See, I got the output. Bhavita, can you share your system? Bhavita. Yeah, please share your system. I would like to see whether you are executing or not. I'm stopping this logistic regression sharing. Now you can share your system. Yeah. Quit. Parenthesis begin, parenthesis close. CLS. Clear screen. Yeah. Notepad. Space logistic. .py. Yeah, your system is not recognizing. For you also same thing we can do. Separately you can open. Separately you can open file, save as. Go to C colon. Go to users. Go to admin. Logistic.py. Select all files. Yes, save. Yes. Now run the program. Python space. Logistic.py. Pip install. Pip install matplotlib. This is a library. It is asking you are using matplotlib library, but you have to install. Enter. Any doubts? My dear students, please ask me any doubts. Somsekhar, I think you are having one doubt. Please ask me. Remaining students, I am sharing that program. You can execute in your laptop. So second year level you are executing means third year, final year you should write you should execute many applications so that you can participate in various conferences, various journals you can publish by getting results. Now run Python, use up arrow, it will come automatically. Up arrow. Up arrow. One more, up arrow. Yes, enter. What it is showing? DLL load failed. Line number, it is not import matplotlib. Yeah, I'm checking. The specified module could not be found. So it is not integrating with that file. Python version, what is a Python version? Let me share file. Directly I'm sharing the file, 1 second. 3.11.1 it is coming. I'm sharing the file directly. Logistic regression file. Save as. Directly you can copy the file. I'm sending the directly logistic. Remaining students, please execute. I'm sharing the file in the WhatsApp. Please copy as it is. Okay. Now you just copy and paste, Amma, Bhavita. This file. This file you can copy directly to the system. Why you are for me it is executed. Just now you have seen. Now you download this file. Yeah, download and go to C drive. Yeah, copy, Control C. C:, users, admin, Control V. Once you just open, yeah, save. Yeah, right click, open with notepad, just go to below. Open with notepad, yes, open. Yeah, Control S. Now minimize. Now you can run. Python space logistic.py. Why that file is not DLL load failed? Remaining students, see, for me it is coming. There is no problem for me. Import error. Okay, do one thing. Pip install space numpy, numpy. Enter. Next, pip install matplotlib. Enter. Next, pip install scikit-learn, scikit-learn. Okay, then pip install sklearn. Enter. Okay. Now CLS clear screen. Python space. Remaining students, please try to execute. Something is wrong. Same thing. Remaining students, please answer. Are you getting output or not? Yeah. Srivani, very good. You got the output. Fantastic, Amma. Okay, just open. Yeah, you got output, then something logistic regression, unexpected class weight. Okay, do CLS, clear screen. Yeah, Python, notepad, please open. Notepad space, logistic.py. Yeah, some line number. You do one thing, you just close this one. You just close this one. Go to WhatsApp. File you can download as it is. Go to WhatsApp. It is showing some error in the program. Go to WhatsApp. Yeah, here, right side, right side. Download that file. Wait. Yeah. Now go to show folder. Show folder. Downloads. Go to downloads. Yeah, copy that file. Downloads. Where is the L? You type L. L, logistic. Click. Where is the file? Where it is downloaded? Show folder. Yeah, download. Go to show folder. Not here. Yeah, first open. No, not here. Do one thing. In the show folder, you just go to below show folder. Yeah, there. Right click. No. In the arrow mark, show folder. Yeah. Download once again. Yeah, click where it is downloading. I'm not finding where it is downloading. No, just go to downloads folder. Not here. Not here. Yeah. Come down. You can type L. You can type L. It is not showing. Yeah, logistic. Enter. It is not showing where it is downloaded. Where it is downloaded. Go to download folder. Right click here. Just my computer. Go to my computer. Go to my computer. Close this one. Yeah, open my computer. Wait. Yeah, download. Click that one, download. Okay, go there, quick access, left side. Yeah, quick access. Below, yes. Yeah, here it is. Logistic. Copy this one. Below. Copy, right click, copy, go to C drive. Users, admin, paste, Control V, paste. This is no longer located in verify the items. Could not find this item not found. So just try again. Okay, cancel. You just go to cancel. 2 folders are there, downloads. Click downloads. Search logistic. Enter. This file SVM is there, but logistic file is not finding here. Where the file is downloading. This PC, click. This PC, click. And local disk, click. Just local disk, click. C drive, click. Double click C drive. Double click. Yeah. Go to program files. Click program files. No, it is not finding here. It's okay. Below there is a folder downloads. Usually download folder is not finding properly in your system. Click, double click downloads. Yeah, click, double click. It is not showing anything. Okay. Remaining students, you got it? See, I'm going to execute this program because we are getting time. See, I'm sharing my system. We'll see that problem. Next, second program, this is the output, I got it. So this is the logistic regression and this is the output, I got it. This is the graph I have generated. Next, decision tree. Next, one more algorithm. Before going to decision tree, yesterday I have explained and we'll see this support vector machine. Yesterday you have executed this support vector machine or not? SVM, I think you have executed. So this is a naive-based classification. Listen carefully. Naive-Bayes classification are a collection of classification algorithms based on Bayes theorem. It is not a single algorithm, but a family of algorithms where all of them share a common principle. That is, every pair of features being classified is independent of each other. Naive-Bayes in 7 easy steps. First step, start, separate by class, summarize data set, summarize data by class, Gaussian probability density function, and class probabilities, and start. Now, this is the formula we are using naive-Bayes classification. P of A by B equal to P of B by A multiplied by P of A by P of B. So we are using Bayesian probability terminology. The above equation can be written as posterior equal to prior multiplied by likelihood by evidence. So naive-Bayes classifier is used to divide the number of objects as a cluster, classification. So P of H by E means posterior probability of hypothesis given that the evidence is true, and P of E by H likelihood of the evidence given that the hypothesis is true. P of H means prior probability of hypothesis divided by P of E, prior probability that the evidence is true. Now see how it works. I am taking data set, weather forecasting data set. Please see here. So weather forecasting, today is rain or not, how do I can predict? I will take past 2 values data, past 2 temperatures data I am taking, sunny, overcast, rainy. Then I am creating a frequency table. How many times sunny, how many times overcast, how many times rainy. Then likelihood table. How many times overcast, sunny, by total number of items we are calculating, you will get likelihood table, posterior probability. So we are using sklearn is a library for in order to calculate a naive-Bayes classification. This is the code. Now I am going to share with you. Okay, what is a naive-Bayes? This how naive-Bayes classification is working. 1 second. I am sharing with my PPT. Okay. So go to run command, opens Python, see, notepad space naive-Bayes. See, this is the file. I am sharing this file. You can also execute parallelly. Why some systems are not executing properly? I don't know what is the reason. In my system, it is executing. See, I am sharing this. So naive-Bayes classification program, I am sharing into the group. Now Python space naive-Bayes. See, I got the scores. I got the scores of 93 point and 96 point, 100, 93 overall. The mean accuracy. Yeah. Yeah, please tell me. I'm explaining this program. Any doubt? I got the output. My screen is visible.
Sir, program is not shared in our group, sir.
I have shared in the group.
No, sir. It's a cyber security workshop, sir.
Oh, sorry. Data science. Yeah, I'm sharing. naive base and logistic, both, and ANN and SVM also I'm sharing. You can download all these files. Now download all these files and execute. See? Now this is the output, I got it. I'm explaining this program. So from CSV, I have taken CSV file format. What is the file name? I'm going to share with you. Data set. So this is the data set I have taken. Naive Bayes algorithm. It is very big program, nearly 174 lines of code. Iris data. You can take it as a file name as a iris data. So I'm giving this file also. Please download this file. My dear students, CSV. I'm giving this file also. You need to keep in your folder. Please take this folder also. This iris, this is iris CSV file. Yeah, this file also download and keep it there, then it will execute. So you need to give the path. Where you need to give the path here, file name, iris is there. File name, iris.csv. Now execute all of you. See here, I have opened iris.csv file also, it is open. Execute this folder or download all the files and run the file. Python space naive Bayes classification. See, I'm getting the output. So iris folder also download in your system. Same, you just save in the same path. Please execute this program. You got it or not? Anyone can respond? Please execute. File name is a naivebase.py. Same file name, and iris.csv, comma separated variable file. That file, naivebase 2 files, you keep in the C drive users wherever the folder you are executing, there you can paste. Then you can run the please see the output. Can anyone share your screen? Please. Please share your screen. I will guide you how to execute the program. Please share your screen. Name. Tab. Use tab symbol. No, remove B. Use tab symbol. It will come automatically. Yes. Enter. Yes. Very good, Amma. You got the output. Same way you can execute all of you. Very good. It is displayed the accuracy. Mean accuracy is 95.33%. Okay. Any other students would like to share screen? Bhavita got output. The first one is 93.33, second one is 96.66, and third one is 100, and fourth one is 93, and the mean average divided by 4. If you do, you will get 95.33. So this is the naive-based classification because iris data set, what it contains, number of users I data. Iris means whether you know, it is also one of the biometric application. So what type of data it consists of? You can see iris data set like Setosa, classifications are there. What is the vision of your eye? Okay, iris, Setosa, versicolor, and virginica. These are the 3 types of iris data is available. It is classified into number of 95% accuracy. We got it. See here, 1 second. I'm sharing my screen. See, this is the data set iris. Iris means the eye, the types of iris, retina, what type of classification, virginica, versicolor, Setosa, 3 types of. So among the 3 types of how many number of rows are there? If you want to see, you can go to last. Okay. So it will 150 rows are there, 150 rows and number of columns. So for this one, it classified as a 95%. Okay, 95% you are getting output. Next. Next algorithm. This algorithm, I think you have executed. Support vector machine for a heart disease data set. Yesterday you have executed. Okay. Bhavita, can you execute, can you share this heart disease data set? Heart disease data set. Please share your screen.
Okay, sir.
Yesterday, I think we have executed that program also comes under machine learning algorithm. Very important algorithm. Data set also I have shared with you. You can copy over there. Heart data set 1 and SVM. File name is SVM. Python program file name is SVM and data set file name is a heart data set 1. Please share your screen.
Shared, sir.
Yeah, okay. Just you have copied that 2 files. Once again, I'm sharing. I'm sharing in the WhatsApp. SVM, you can download SVM. I'm sharing that 2 files once again. Heart data set. Yeah. This data set also copy in the folder. And SVM. SVM already I have shared. Okay. These 2 files download and execute. In the WhatsApp I have shared. Yes. Users, admin. Hard data set file is not there. Yeah, that one copy, Control C. Go to C drive, users, admin, Control V. Yes. Now you can execute. Go to run command, CLS, Python space, svm.py. Wait. Program is running. Yes. So number of instances are 61. So 29 patients, 29 patients may get chance of heart attack, and 29 patients won't get a heart attack, and 32 patients there is a chance of getting heart attack. So this is called confusion matrix. Based on the confusion matrix, we are calculating the accuracy and parameters we are taking, like precision, recall, F1 score, support. These are the parameters we are taking, and we are executing support vector mission is a classification algorithm. Number of patients are 61. Total patients data set is there. You can see name of the person, symptoms of the person, like that data set consists. 61 patients are there. That complete data set I have taken as input and applied a support vector machine. Then finally it gave results like 78, overall accuracy is 67%. Accuracy is 67. Remaining students, can anyone not getting output? Please share your screen. Very good, Amma Bhavita. You are executing today. Yesterday it gave very big problem. Today you are getting outputs. Next, another student. One more program I am going to explain. Listen. So support vector mission. This is the data set. See, heart. Wait. I didn't share my screen. I think I will share my screen. Now you can see. So this is the data set. You can see the data set labels here. Age of the person and gender, and 1 means male, 0 means female. Then CP, symptoms of heart attack, cholesterol is there, and all the symptoms of the heart disease. So the target class is 1 means there is a chance of getting heart attack, 0 means there is no chance of getting heart attack. This is the data set. Okay. Now, next, this is the output. I got it same. She got same output. Then KNN, K nearest neighbor algorithm. I will explain this algorithm. Listen carefully. K means assumption, number of classes. K nearest neighbor is a very simple, and you can understand versatile and one of the topmost machine learning algorithm. KNN used in the variety of applications such as finance, healthcare, political science, handwriting detection, image recognition, and video recognition, etc. In credit card ratings, financial institutes will predict the credit ratings of the customers. In loan disbursement, banking institutes will predict whether the loan is safe or risky. In political science, classifying potential voters in 2 classes will vote or won't vote. KNN algorithm used for both classification regression problem. KNN algorithm based on feature similarity approach. See, this is the KNN has the following basic steps. See, there are 3 classes, x-axis and y-axis, to classify the class A and class B. So Python steps: start, calculate distance, find closest neighbors, vote for label, stop. So this is the step 1. Step 2, see, first step, we are finding the initial data. We are assigning the values, then calculate distance, then finding neighbors and voting for labels. This is the algorithm. This is a program. This is the final output. Okay. So now I am going to share with you this K nearest neighbor algorithm. Wait. Okay. First, let me check notepad space. KNN.py. So K nearest neighbor technique. This algorithm also I am sharing with you. I'm checking the data set, wine data set. Okay, that also I'm giving. So here I'm taking the labels like weather, temperature data set. 1 second, I am giving the data set. Okay. 1 second. Python space. Yeah, it is running. It is running. Please take this program, data science workshop. Please download this file. Yeah, please download that file. You can open knn.py. So wine data set we have taken as input, wine data set. You can download from the WhatsApp knn.py. You can run the program. Please share, Bhavita. You can share your screen. These all are machine learning algorithms. You downloaded that file?
Executed also, sir.
Oh, very good, very good. Remaining students?
They also got output, sir.
Okay. Anyone not getting output, please share your screen.
Sir, all members got output, sir.
Okay. So wait 1 second. So today I'll summarize. I think time also. So with this one, I'm closing machine learning algorithm. Algorithms, 5 algorithms you might have executed. And a few students not yet subscribed my channel. Daily I'm uploading these videos. If you want to listen, already I have explained a few more workshops this channel. And if you are having internet, please subscribe my channel and write comments on the each video. So this is my channel. Tomorrow we'll see the deep learning concept and followed by the COVID-19 virus detection application. Very interesting. And Omicron virus detection, monkeypox, Ebola virus, and lung cancer, and prostate cancer, breast cancer, prediction detection. Various applications tomorrow we'll see. Okay, and followed by the AR/VR technologies. So any doubt so far, if you are having, please ask me.
No doubt, sir.
Okay, ma. So shall we meet tomorrow? Last day. Okay.
Yes, sir.
Okay. Okay, bye, ma.